Hey everyone, thanks so much for coming today. My name is John Noonan. I'm a senior product marketing manager here at Redis. And I just wanted to start by asking how many of you have heard of Redis before or have applications that use Redis? Awesome. So whether or not you're completely new to Redis or you're a seasoned Redis expert, hopefully you learn a thing or two here today, because today we're going to be discussing how you can reimagine your data layer with Redis. So today we're going to cover what is Redis, especially for those of you that aren't as familiar. We'll get into this concept of the data layer, what it is and why it's important to your business and your applications. Then we'll dive into some of the limitations and challenges of all the services that make up today's data layer. And then finally, we'll finish with 5 ways Redis can help you reimagine your data layer to overcome these limitations. So we'll start with what is Redis. Redis is an in-memory data store, which means that data is stored in RAM so that it's incredibly fast. It gives you sub-millisecond latency to help power a whole host of modern application use cases in real time. As a key value database, Redis is incredibly flexible to support many popular data models and use cases, which makes it a perfect choice for just about any type of modern application. Redis is available as a very popular open source technology, as well as a fully functional enterprise-grade software via Redis Enterprise. And because of its speed, its flexibility, and its overall capabilities, Redis has become one of the most widely loved and most used database technologies available anywhere today. And just because of this, it's really become one of the cornerstones of today's data layer. But what is this data layer that I keep speaking about? Basically, it's the collection of technologies and services that process, deliver, and store data for your applications. Obviously, the data layer is absolutely fundamental to modern apps. They're more data-driven than ever. And these technologies can really vary greatly. They can be open source, or they can be a fully functional paid enterprise-grade offering. They can serve all different types of data, from your more traditional relational database to more modern use case-driven databases like a time series or a graph database. They can be self-managed, like with open source Redis. They can be available as a cloud-managed service, like with Elasticache for Redis. Or they can be available as a fully functional enterprise database as a service, like with Redis Enterprise. And all of these different services can be, sometimes they're installed on premises, sometimes they're running in hybrid deployments, sometimes in multi-cloud. Ultimately, there's a lot of choice, and it's up to each business to determine which databases, which data technologies, and which data layer strategy works best for their business and their applications. So there's this data layer, and it's one of the foundations of modern applications. Well, who's responsible for building and operating it? It's likely many of you here today. It's primarily owned by developers who are building applications, they're writing code, and they're building the applications that leverage all this enterprise data. By DevOps teams that are responsible for pushing new code out and managing and operating the applications and all of their components. And then by architects who go out and vet and select, and then select technologies, and then design and build the applications and their components. Now, I wish I could say these were all easy jobs, but we know that there's significant challenges. So let's get into those a little bit. We'll start with developers. All of the complexity in today's tech stack introduces a lot of challenge with them for velocity, because there's multiple different coding languages, there's multiple clouds, lots of data types, and all this complexity ultimately slows down one of their primary goals, which is getting new code out and getting it out quickly. And they also struggle to avoid troubleshooting and getting pulled into troubleshooting application issues when applications aren't performing or they're unavailable. Next, we'll get into DevOps teams. They also struggle when it comes to troubleshooting applications, because when things go down, ultimately they're the ones responsible for getting them back up and running. So when things go wrong, it's a big problem for the DevOps teams. They also struggle with complexity, because there's so many different types of data solutions out there and technologies that they need to know how to operate, and there's also more points of failure. So this complexity breeds a lot of additional risk for them. And then inevitably, when things do go down, the DevOps teams often struggle to find support and access to true experts in the technologies that their applications are built on to get them back up and running as soon as possible. Finally, architects. The architects need a lot of agility to make sure that they're able to react to constant changes and pivoting from the business. These changes can be drastic and they can be frequent, and architects need to make sure that they're choosing technology solutions that can kind of come along for this wild ride. They also struggle to ensure that the technologies that they're investing with today are going to be able to scale to support future growth, and they're not going to leave them trapped with investments that work today but maybe don't work tomorrow. And then finally, they need to maximize all the value of their investments and their time and their budget without completely breaking the bank. Many of these challenges that we just discussed are directly a result of the limitations of today's data layer. And those key limitations are performance, complexity, and cost. So let's talk about performance. Customers expect applications that perform in real time at all times. But many of the data solutions in today's data layer just can't meet that need. They're too slow. They leave users waiting as databases struggle to load large volumes of data, or as data has to travel from infrastructure in one region to users located geographically in another region. They often struggle to scale, so they might be performing in a smaller environment, but once the application has grown and now they're processing data for tens of thousands or hundreds of thousands or millions of users, they just can't perform under that load, and it leads to laggy applications and frustrated users. And finally, applications and their data have to always be available, but many of the technologies in today's data layer just can't meet these needs for availability. And they also leave businesses and their customers with outages and possibly lost data. The second limitation is complexity. The data layer is just too complex, as I mentioned before. There's an ever-growing amount of services to work with new data types, to work with new use cases, and ultimately this leads to businesses just kind of cobbling together a data layer of disparate services. And all of these different services the developers need to learn and the DevOps teams need to learn how to support. And this complexity, again, breeds a lot of additional risk. It's much more difficult to manage, and it really fragments the data layer across all these different services. And the third limitation is cost. Costs are a serious challenge to the data layer. Most data technologies that can overcome that challenge around performance are going to introduce a new challenge, which is cost. That means that if businesses want their data services to perform well, they're going to have to pay a lot of money for them. Data storage is also incredibly expensive, especially at scale. And businesses work with, as you know, work with huge, vast quantities of data, and the cost of storing that data and the size of that data set is only growing. Additionally, because the data layer is fragmented into multiple services, that means that businesses are paying more bills to more vendors, and the costs add up. And then finally, just because the data layer is so complex, you need more experts to manage it, and it's more difficult to manage, which means it's more expensive to manage. So the top data layer limitations: performance, complexity, and costs, and they have real-life implications on developers, DevOps teams, architects, their day-to-day, as well as businesses and their applications. Well, here at Redis, we don't just accept these limitations, we really challenge them. So let's dive into 5 ways that Redis can help you overcome these data layer limitations to build a more capable, better performing, and cost-effective data layer. The first way is that Redis provides you with a fully loaded real-time data platform. And this really helps the developers and the DevOps teams reduce the complexity that they often struggle with. So let's say you're building a real-time application in AWS, kind of the old school way. You would need to use a whole combination of different systems and services. You would need Kinesis to collect your data, DynamoDB to persist your data. You need Elasticache to quickly access frequently used data. You might also need TimeStream for analytics, OpenSearch for searching, and the list just goes on. But the problem is that these are all different systems. So to make them work together, you're going to need Lambda functions, SQS, and probably even a few other services as well. And then all of a sudden, you have a slow, complex system that requires multiple experts and is difficult and expensive to manage. Well, with Redis Enterprise, you can really minimize this complexity with a unified real-time data platform. You can use native Redis data types like streams for collection, pub/sub for distribution, lists for queuing, time series for analytics, Redis search for indexing. And because this is all in one system, it's a much better approach and a much less complex approach. You got a single, fully managed system that's blazing fast, simplified, and cost-effective. The second way is that Redis really allows you to unify your cache and your primary database. Redis is widely known for caching, but it's really since evolved into a primary database. And in fact, it's commonly used as a primary database for thousands of business applications. And this is because, as I mentioned before, Redis serves as a multi-model database, and it allows you to build modern applications with incredible performance. You can use Redis data types like streams, again, for the collecting and distributing, JSON for storing JSON documents, search for indexing, graph for relationships, time series for application monitoring, Bloom for gaming, fraud detection, and leaderboards, and then AI for a real-time AI feature store and for inferencing. And this ability to use Redis Enterprise as a cache and a primary database for so many different types of data and use cases eliminates the need for you to have a separate cache and a primary database, which ultimately reduces the complexity and the latency of having to have two separate systems. The third way is by providing you with the flexibility to deploy anywhere, wherever your applications are hosted. As I mentioned, complexity is an absolute key challenge for the data layer, but Redis can really help reduce this complexity with its ability to deploy wherever your applications are hosted. We know that multi-cloud and hybrid are the new norm, and Redis was built to support that reality. With Redis Enterprise, instead of having multiple services across many clouds, you can deploy a single unified hybrid and multi-cloud data layer all in one service. And this eliminates a lot of the common challenges with siloed data or vendor lock-in. And because all of your data is stored in a single system, you have the freedom to easily move from one environment to another. And Redis Enterprise is available on all three of the major public clouds to make your multi-cloud deployments a lot easier. It's also available as downloadable software to support your on-premises or your hybrid applications. And ultimately, this ability makes for a much more flexible, much less complex, and much more cost-effective data layer. The fourth way is that Redis provides you with the performance, the scalability, and the resilience that's needed to power modern applications. We all know today's users are demanding, and they expect absolute top-notch performance from business applications. And this means that the data layer has to meet those expectations as well. It has to be lightning fast. It has to be highly scalable and able to support growth in both user volume as well as expansion into new regions. And it has to be highly resilient to make sure that the data that your applications need is always available, and it's always available to your users. And as a real-time data platform, Redis Enterprise was built to meet these very difficult needs. It was designed to help these needs with the ability to deploy multiple primary Redis clusters with Redis Enterprise's active geo-distribution. Distributed across the globe, Redis Enterprise offers truly enterprise-grade performance, and it gives you things like sub-millisecond speed for both reads and writes. It gives you 99.999% uptime to ensure that your application data, your data is always available to your applications and your users when it's needed. It helps you deploy that unified hybrid and multi-cloud data layer, and it gives excellent protection against data loss to make sure that your data is always available when you need it. And then the final way is Redis helps you save money by eliminating this trade-off between performance and costs. With Redis Enterprise, you can have incredible performance without completely blowing out your budget. And that's because Redis Enterprise is optimized both for performance and for costs. It gives you the sub-millisecond latency that Redis is famous for. But it also offers things like flexible pricing to ensure that you can start small and you can scale up by only paying for what you need and what you use. It offers things like Redis on Flash to maintain that lightning-fast performance, but also helping you save a significant amount of money, and actually up to 80% on your infrastructure by tiering between RAM and Flash. So you use less expensive RAM, and you only use it where you really need it. And it also gives you better efficiency. So you get things like multi-tenancy and improved CPU utilization to help your business get the most out of the infrastructure that you're paying for. The bottom line is that Redis is really revolutionizing and reimagining the data layer by providing a highly performant, simple, and cost-effective real-time data platform. Thanks so much for coming to the session today and for your interest in learning more about Redis. Feel free to stop by our